Hi all. So in this video we are going to learn about weak entity sets. So we have till now learnt about the entity sets where we have attributes, and one was something like a key attribute. Okay. So we have seen something like that. It could be anything instead of A. I just meant it for an example. But let's say, so definitely for an entity set, we have a one attribute as the key attribute. Okay. So this was considered for previous before examples and all those models we have learned about. But let's say we have an entity set and we don't have any key for that. Entity set with no keys. Now, if this is the condition, we will call this entity set as weak entity set. Okay, so this entity set will be called as a weak entity set, and it will be represented by two rectangles, one rectangle within another rectangle, like this. Okay, so this is a weak entity set. Now, when there is a weak entity set, so attributes uh, which are present, attributes would be definitely present for a set entity set. So attributes of weak entity set are not able to distinguish. Okay, attributes of weak entity set are not sufficient to distinguish between the entities, right? Are not sufficient to distinguish between the entities because we don't have a key. Why do we need a key? Because we want to distinguish between or differentiate between the entities of an entity set. But if we don't have a key attribute for an entity set, then definitely we can't distinguish between two or more entities of an entity set, right? So definitely for weak entity set, we need something so that the attributes can be distinguished from each other. So weak entity set depends upon the strong entity set for the purpose of distinguish or differentiation. Okay, so weak entity set depends on some strong entity set for distinguishing between the attribute. Okay, so this strong entity set on which the weak entity set depends upon is also known as the identifier, or sometimes it is also known as the owner entity set. Okay, so this is important that the strong entity set or the identifier entity set or the owner entity set, all three are same. Okay, uh, now we will see about how we can distinguish between the weak entity set and the strong entity set. So we have seen that if we use this kind of diagram, this is the weak entity set. So if we have some strong entity set, let's say this is a strong entity set. So this weak entity set depends upon this identifier or strong entity set for the purpose of distinguishing between the entities. Okay, so this is known as the identifier set or the owner entity set. Right, now if there is a dependency, then definitely there has to be some relationship between these two set, right? So this set has to be related with this set with the help of one relationship, right? Okay, so this relationship, so every entity of the weak entity set must be involved in this relationship. That's how we can distinguish, right? So if you say that this is the weak entity set and it depends upon a strong entity set, let's say this, okay, so there should be a relationship between these two set, between the entities of these two set. And since we want to distinguish each entity from each other, so all the entities must be involved in this relationship model. So there should be the total participation at this weak entity set. This is a must because this has to depend upon this. This is the owner set, owner entity set, and this is the weak entity set. This is has to be a total participation should be there, because every entity of this weak entity set must be related to the relationship set, right? And each owner can have a many entity set, like this this should be a many. Okay, so this is many relationship M. So every owner, every entity of the owner can have a many relation. I mean, every entity in this owner entity set can be related to many weak entities of the weak entity set. Okay, so it should be 1 is to M a relationship between the owner and the weak entity set. Okay, so it should be the 1 is to M relationship, right? Why it is necessary? So first thing is necessary that there should be a total participation at the weak entity set, and the second constant should be uh, between the owner, each owner, each owner is related to one entity of the owner entity set, can have can have many weak entities. It is not a necessity, but it can have many weak entities. Okay, and each weak entity and each weak entity must have one owner. Okay, so this is a required condition that weak entity must have one owner. Okay, like this. So this is between the owner and entity set, we have 1 is to M mapping, or if we say between weak entity set and the owner set, we have M is to 1 mapping. So it is just vice versa. It depends upon what we take first. Okay, so let's illustrate this entire scenario with an example. Let's say we have an owner set, that is account, which has attributes like there is an account ID, of course, that is the key attribute, and we have one account name. Okay, so these are the two attributes, and we have transaction. Now for transaction, this is a weak entity set. Why it is a weak entity set, I would like to say, because it has two attributes like TID, transaction ID. Okay, and there should be an amount. Okay, and there's one more entity, that is, let's say, the state in which this transaction has been taken place. So the TID represent the transaction ID. So let's say this is not the key attribute, because for two transaction happening at the same time stamp and at the same time and by the same person can have the same transaction. So it cannot be unique for every single entity of that. Okay, so let's say this is not the key attribute. This is just a partial key. Why it is known as the partial key is because we don't have the this as the key attribute to determine other entities. Like we can't use this TID as the candidate key for this entity set. Okay. Now this weak entity set has to be dependent upon the account entity set, so that this transaction ID could be related to a particular account ID, and that way it can distinguish among the entities. Okay, so definitely there should be a relationship diagram, a relationship, so that each transaction belongs to a particular account by which it can be distinguished. So, okay, so there will be total participation here, and this should be 1 is to M relationship. Okay, so this is a must. Total past participation is a must. This is our owner entity set, because the TID has to be dependent upon the AID, that is the account ID. It has to be associated with each account so that we can distinguish among all the entities, right? So this way we have this weak entity set and strong entity set relationship. So this is one example. Another example, let us illustrate it if you want, like if we have this transaction. So for we have this TID and we have this amount and we have this status, sorry, it's status, not states. Okay, and we have the transaction ID, let's say T1, and for T1 we have the amount 5K and it is the status is withdrawn. Then we have T1 and the amount is 5K and it is credited. Okay, so you see TID is not the key here. Okay, and then we have another transaction T2 with 5K amount and it is credited, and again we have this T2 transaction with 4K and it is also debited. So these transactions are there, so TID is definitely not the key. So no single attribute of this is a key, neither TID nor amount nor status. So definitely this is a weak entity set. When it is a weak entity set, then we don't have any key for that set. And for the entities to distinguish, we need for distinguishing between the different entities, we need a strong entity set or the owner entity set. And if it is an owner entity set, we need to have a relationship which has the total participation at the weak entity set side, and each weak entity set must be related to one entity of the strong entity set. Okay, so this is the relation. If we see it as a model, so let's say we have this account ID, AID, and we have amount. So AID is the key here. So this will be A1, A2, A3, A4, and the amount associated with each account would be something. Okay, we don't have to worry for that. And again here we have this our weak entity set. So for weak entity set, we have already sent that TID is there and there is some amount and there is a status whether it is credited or debited. Okay, and here we have this TID as T1, T1, T2, T2, and this is 5K and this is 5K, 6K and 4K, and the status is debit, then credit, then debit, then credit. Okay, this way. So now we need a relationship so as we can relate between these two. So we can use the TID and AID because TID is the partial key we have considered. Okay, so if we have the relationship as belongs to, so we can relate the TID with the AID here. So if AID is this, so this is TID. Now there should be total participation. So TID, all TIDs must be involved here. So let's say T1 is related with account A1 and T2 is related with account A2, and again T1 is related with account A2. Okay, and T2 is related with account A3, let's say. Okay, so if this is the case, then we have here TID and AID as the key for that. Okay, so this way we can construct a entity relationship diagram. Now, if you ask that there is a total participation here, so all the TIDs are involved. Okay, so T1 is involved, T2 is involved, T1 is involved, T2 is involved. So if you see here, like T1, this T1 corresponds to this data, and this T1 corresponds to this data. Okay, so in this way, this T2 corresponds to this data, and this T2 corresponds to this data. Okay, so this way we have taken every entity. So in this way, we can say that every entity is related with one entity of this owner entity set. Okay, so this way everything has come up, and it is every entity is shown in the relationship. Okay, so this way it has been shown, and of course there is a one to many relationship, and this is the AID, and A1 corresponds to T1 and A2, and this A2 corresponds to T2 and T1, and A3 corresponds to T2. So this way we can construct the ER model, ER model diagram is allowed to represent the weak entity set. Also, we can have the multi-valued attribute also in the ER diagram, but in RDBMS relation, the multi-valued attribute are not allowed. Okay, so if we try to construct the minimal RDBMS diagram for that, if we are asked to construct the minimal RDBMS diagram, so we can't have multi-valued here. Attributes are not represented here. So this not allowed. Okay. And also this weak entity model, weak entity sets. Okay. This also is not allowed. Okay. So this too can only be represented in ER diagram but not in RDBMS table design. Okay, so this is one difference between the ER diagram and the RDBMS relation, because in RDBMS relation, the weak entity set and the multi-valued attributes are not allowed, right? Now, definitely, if we still need to construct the minimal RDBMS table, then definitely we need to have two tables. One is the account table. Of course, we can't combine these two tables with AID and a name, account name, and AID being the key. And then we have one table that is transaction belongs to. We can combine the relationships as a transaction and belongs to, and this table will be consisting of the AID, TID, and the amount and the status, of course. So these two can be combined together with this as the key and this being the foreign key. Okay, so minimal RDBMS table, if you ask, minimal RDBMS table is 2 and 1 foreign key, right? So this way we can construct. However, in our DBMS table, this weak entity set is not allowed. Why? Because we can't have any key to distinguish between the entities. So there has to be a dependency in the relationship model. So that is why it is allowed in entity relationship model, but not in RDBMS model. Okay, so this is all about the weak entity set and how we can construct for the minimal RDBMS design. We can also look into how we can construct the RDBMS design for a different ERD model, that is the entity relationship model, and we can see how we can have the keys for that. Okay, what are the foreign keys, what are the candidate keys, and all. So this is whole for today, and this is the entire series for the ER diagram model. We can have multiple questions based upon the conversion, as I suggested, and then we can perform the normalization and all. So this can be further extended into that part. So, okay, so that's all for this video, and keep watching. Thank you very much for watching. Bye.